Greetings, everyone. I'm Philip Hamilton. I'm a senior scientist at the Anderson Cabot Center for Ocean Life at the New England Aquarium. I'm going to give you an update on the photo identification catalog and the much anticipated results of this year's whale naming effort. First, I'd like to acknowledge my co-authors and note a couple of transitions in our staff. We're sad to announce that Mariana Hagblum has moved on and excited to announce that Kate McPherson has joined the catalog team. I'd like to start by providing a brief overview of the catalog for those new to the consortium. The catalog is also called the Photo Identification Database and contains all photograph sightings of right whales, as well as some satellite tag locations of known individuals. The catalog differs from the sightings database at the University of Rhode Island, which has sightings of all species, including dolphins, turtles, seals, and large fish, along with effort data, and has some records going back as far as the 18th century. The two databases can be linked by fields that are updated annually. Many people rely on the catalog data, so it's important to understand how it changes from year to year. Two things that have impacted the catalog recently are COVID and changes in whale distribution. Due to COVID, some survey effort in 2020 had to be canceled due to safety concerns or international travel prohibitions, and other surveys were reduced while teams developed COVID safety protocols. This reduction in survey effort resulted in fewer sightings submitted to the catalog, and so far fewer individual whales identified. But I should note that the 2020 data are not complete, and the number of individuals identified will likely increase. The other big impact on the catalog is whale distribution. As most of you know, right whales shifted away from several important feeding areas starting in 2010 and 11, the Bay of Fundy, Roseway Basin, and Great South Channel, and since then have moved into the Gulf St. Lawrence and the waters south of the Cape and Islands. One surprising aspect of this change is that the 130 plus whales that now use the Gulf of St. Lawrence are extremely loyal to that area. They go back year after year. Such consistent habitat use is unprecedented for right whales. We've also noticed an intriguing partitioning in habitat choice among the 2021 calving females. The younger females all regularly feed in the Gulf, whereas the older females have never been seen there. An example of the latter is Grand Teton, a 44-plus-year-old female who I mentioned last year. She disappeared for 9 years before being seen again in 2019 and then gave birth in 2021. So there appears to be several levels of partitioning in the population now. Under the new distribution regime, we're still trying to figure out whether those whales seen less frequently have died or are using additional un- or under-surveyed habitats. So keep the potential impacts of COVID and distribution shifts in mind as I present the current status of the data. There are currently 771 individuals in the catalog, up 10 from last year. Of those, 442 were presumed to be alive in 2020. That is, they'd been seen in the previous 6 years. Remember that these are simple counts of identified whales, which is a less sophisticated method than the modeling used for the report card. We know that many whales die sooner than 6 years after their last sighting, and I'll discuss this further in a minute. We're particularly concerned about the females in the population. For the first time in several decades, the percentage of females presumed alive in the catalog did not decrease. It went from 38.2 to 38.7. I wouldn't exactly call this good news, as it was 46.5% in 1990, but at least it hasn't gotten worse. This is the matching status of the catalog data for the last 12 years. A substantial increase in submissions in 2019 set us back a bit, and for that reason and delays in submissions, the 2020 data are a bit behind where we usually are at this time of year by a couple percentage points. Not all 2020 data have been submitted, and not all of what has been submitted has been entered. So as I show you the next few graphs, remember that the 2020 data are not complete. This is the breakdown of the presumed alive population for the last 21 years. The colored parts are counts of whales seen that year. The purple are whales that had been seen in previous years, and the red are whales first seen that year, almost all of them calves of the year. The white are whales that had been seen in the previous 6 years but not seen in that year. The relatively little red in recent years is a combination of fewer calves being born and delays in being able to add those calves to the catalog, and I'll talk more about that in a minute. Up through 2011, we saw about 83% of the whales presumed to be alive each year. Since then, the percentage has been about 68%, but we know the presumed alive count is not accurate. This slide shows that between 1990 and 2011, the average difference between the minimum number alive and presumed alive was 35 whales. As a reminder, the minimum number alive is the number of whales seen in a given year, plus any whale not seen that year, but seen both before and after. So it's a very solid minimum number. This means that 35 whales presumed alive each year were actually dead because they were never seen again. If this pattern held, the real presumed alive number in 2020 would drop from 442 to around 407. Starting in 2012, the parallel lines began to diverge, and the average difference between the two from 2012 to 2015 was 63 whales. This divergence is primarily due to an increase in undocumented mortality, but a part of it may be caused by some whales going elsewhere, like Grand Teton. A reminder that the minimum number alive always drops inaccurately low at the end of a time series due to few after years. In past decades, 50 to 100 whales were not seen in a given year, but seen before and after. So the minimum number alive in recent years could increase. However, that historic pattern of many whales only seen before and after conflicts with the PACE model population estimate for 2019. The PACE model, which mirrors the minimum number alive closely, shows 366 whales alive in 2019, and we identified all but 5 of those whales, which would be a 99% sighting rate. The minimum number alive for that year is 362, with all but 1 of those whales seen that year. I expect that with more after years, the minimum number alive will increase. The question is, by how much? Here are all the mother calf pairs for the last 21 years. The purple represents calves that have not been added to the catalog yet. Some will never be added. We did not have adequate photographic or genetic data to ID them. Others will eventually be identified, but that process can take many years, as you will see in a minute. These are the changes to the catalog since last year's meeting. Due to time constraints, I'm going to focus on just one of the new whales added. This is the 2012 son of 3995. He was seen as a calf in May 2012 offshore on Georges Bank and not seen again for 6 years. It took 8 years to add him to the catalog due to the scarcity of his sightings. And as I reported last year, there are comparable delays when identifying calves genetically, meaning we have a sample from it as a calf and another sample from a well-photographed sighting of it in a subsequent year. On average, it takes 5 years before that second sample is obtained. I should also mention that the distribution shift has added further delays to genetic sampling of juveniles as whales have moved into habitats that are largely surveyed by planes, and it's pretty darn challenging to biopsy a whale from a plane. These are the 11 groups that contributed more than 10 sightings in 2020, although some large data sets from Canada, including Transport Canada, have yet to be entered. We had a lot of opportunistic sightings and had a total of 89 groups or individuals contribute so far. Here is the breakdown of the distribution of those sightings, which I will not describe in detail because I'm running out of time. This is the breakdown for number of unique whales seen by group for 2019, the last year for which the identification data are complete. Besides the 14 shown here who saw 10 or more whales, there were another 57 groups or individuals who saw less than 10 whales. All right, on to the whale naming. A lot of people participated this year, and there were a lot of good names. This was the first time using ranked voting. Everyone had to rank all names in order of preference. If a name did not get more than half the votes, the software iteratively sifted through the names until one got the majority. All right, so here we go. 1017 was named Batman for scars on the right lip that look like Batman's mask, eyes, and mouth, and the nominator gave a graphic example. 1204 is named Spindle for the symmetrical peninsulas that resembled a spindle on a banister. 2303 was named Jib for the triangular scar in the front of the bonnet that looks like a triangular sail. 2420 named Flounder for the double peninsula on the left side of the head that looks like two flounder eyes. 2740 named Chauve. Chauve is bald in French, and this whale has a particularly bald callosity and is the son of Baldy. 2743 Ellipsis for the three post-blowhole callosities that look like the three periods in a row, which is the symbol for an ellipsis. 3351 Dune for the distinctive big lips that look like sand dunes. 3510 Twister for the scar on the peduncle and insertion that looks like a large tornado. In this case, Scrimmage won the first round 5-2, but in the ranking, Twister won. 3596 named Loki. Loki is the trickster Norse god who can disappear, and 3596 has very few sightings. The rank voting ended up with this whale getting all 20 votes, unusual since most just got slightly over 10 to end the ranking and win. 3790 named Fission for the fused islands on the center of the head. 3812 named Nimbus for the big scars on the lip that look like clouds. 4091 named Quill for the white scar on the head that looks like a pen. 4150 named Accordion for the prop scar. 4360 named Musketeer. The three islands fused in the front of the head look like the three musketeers, and the scar behind the post blowholes look like a fancy feather on a musketeer hat. Canoe actually got more votes initially with 7-4, but Musketeer won in the rank voting. 4423 named Nebula for the white scarring on the right dorsal fluke, but also on the head. 4440 named Avalanche for the severe peduncle scarring resembling snow. And this is the second name to win in the ranking with 20 votes. It was a landslide. 4457 Seamount for scars on the back that look like a chain of seamounts. And Cumulus won this initially 5-4, but lost in the ranking. And finally, 4510 was named Sheila. This whale was disentangled by Captain Joe Howlett and the crew of the research vessel Sheila in the Gulf of St. Lawrence in July 2017. So thank you so much for your attention, and thank you as always for this incredible community and the collaborative nature that we all share, and to the National Fisheries Service for their longstanding support of the catalog. I look forward to your questions at the consortium.